Welcome, everyone. Thank you for joining me today. We are here to dive into a presentation titled Microprocessing the Hippo's Waste, a case study in deconstructing monolithic problems. This session is all about strategy and perspective. When we encounter a project or an issue that feels massive, messy, and overwhelming, much like the monolithic shape on the left, our natural instinct might be to pull back. However, by shifting our focus toward microprocessing, we can systematically break these large-scale challenges down into organized, manageable data points and actionable steps, as illustrated by the grid on the right. Today, we will explore the practical steps of this deconstruction process and how it can lead to more efficient problem-solving in any complex environment.
When we examine the concept of the brute force of a singular output, we find a remarkable illustration in the natural world. Hippos are creatures of immense physical power, yet a significant portion of that strength is specifically required for the singular task of shaking their tails to spread dung. This behavior demonstrates how massive energy can be channeled into one definitive, high-impact action. It highlights the importance of focusing vast resources toward a single, purposeful result, ensuring that every ounce of power contributes to a specific, intended outcome.
Fine-grained processing often occurs at a scale so minute that the individual components and their outputs remain entirely invisible to the observer. This concept is poignantly captured by the observation that, while ants are constantly consuming food, the resulting waste is so granular that it fails to register in our field of vision. This invisibility is a hallmark of highly distributed and micro-level systems. When operations are broken down into such small, frequent increments, the sheer volume and speed of the process can obscure the tangible evidence of each individual action. In this session, we will examine how these nearly imperceptible layers of activity form the foundation of complex systems, and why the most critical elements of processing are often those that never catch the eye.
This visual explores the dynamic between collective power and individual scale. On the left, we see a singular, massive entity, a representation of a challenge or goal that appears insurmountable at first glance. On the right, we shift our focus to the individual scale, illustrated as a network of smaller, distinct units. While these individuals may seem fragmented or small in isolation, they possess an incredible potential for impact. Much like the example of ants, which can move objects many times their own size through coordinated effort, the strength of a group lies in its ability to synchronize individual actions. This comparison highlights that large-scale change and heavy lifting are not accomplished by a single force, but through the aggregated power of many smaller contributors working toward a shared purpose.
To understand our current architectural challenges, let us examine the metaphor of the hippo in the code base. This illustration compares the rapid accumulation of technical debt to the overwhelming nature of a hippo's waste. In just a 3-day window, our team generated 70,000 lines of code, a staggering volume that prioritized speed over structure. The resulting reality is a massive monolith, represented here as a tangled big ball of mud. This high-velocity output has left us with a complex web of interconnected dependencies that are increasingly difficult to navigate, test, and maintain. We must now address the long-term implications of this monolithic growth to ensure our system remains sustainable.
The shift in strategy presented here centers on a key realization. To minimize waste, we must move away from monolithic processing. The new direction is defined by the transition from a single large entity to a system of granular, parallel components. By breaking the workload down finely, as seen in the move from the singular circle on the left to the structured grid on the right, we can process tasks simultaneously. This approach not only reduces bottlenecks, but also provides the clear, optimized direction needed to drive efficiency across the entire operation. Our strategic approach focuses on microprocessing the monolith. We aim to refactor our current 70,000-line monolithic codebase into discrete, manageable submodules. The core principle of this strategy is to ensure each submodule acts as an independent ant, processing a small, well-defined piece of the larger problem. By adopting this model, we are intentionally trading monolithic complexity for modular simplicity, ensuring our system remains scalable and easy to maintain.
To maintain discipline within the colony's workflow, we rely on a specialized toolkit. Our foundation is built on test-driven development, which provides a critical safety net. This allows each individual ant to work independently with high precision at the micro level, ensuring that changes do not compromise the integrity of the entire system. Complementing this is TaskFile, which we use to automate and orchestrate our refactoring tasks. It functions as the colony's essential communication system, making every process repeatable and ensuring seamless coordination across all tasks.
To guarantee the integrity of our development process, we implemented a system of parallel processing focused on cross-verifying multiple models. By running the original AMP main code base alongside the refactored OpenCode submodule, we performed continuous checks for functional parity. The verification engine compares the outputs of both systems to ensure that the new subcomponents mirror the original logic precisely. This rigorous approach allowed us to confirm absolute consistency throughout the refactoring process, ultimately leading to the validated state represented by the final checkmark.
The scale of this project demanded a level of computational power that is often hidden from view. As highlighted by the quote, "I desperately needed large token capacity," our primary challenge was securing the resources necessary to handle the sheer volume of data. Even after breaking down the monolithic structure into smaller parts, the processing requirements were still substantial. The success of our entire parallel verification strategy rested on having sufficient infrastructure to support these intensive computational needs, demonstrating that the right resources are just as vital as the strategy itself.
We have reached a pivotal turning point in our progress. As the evidence suggests, we have now passed the milestone for practical implementation. This signifies that our foundational work has matured beyond the experimental stage and is ready for real-world application. We are moving from the realm of theoretical potential into a phase where these systems can be deployed effectively to drive tangible, measurable results. The concept of moving from Hippo to ant represents a fundamental shift in mindset when addressing any monolithic challenge. Often, we are confronted with problems that appear overwhelming, represented here by the large, singular mass on the left. The breakthrough, however, does not typically come from a specific tool, but rather from a change in perspective. By breaking a massive, complex problem down into its smallest possible components, much like a colony of ants breaking down a large object, we can begin processing these pieces finely and in parallel. This methodology transforms an intractable monolith into a series of manageable tasks, creating a significantly more effective and efficient path toward a solution.